of the most important places, geologically speaking, on the planet. And I'm going to see if I can sort of help frame that for you. Remember, younger folks are not going to remember this, but remember grades 8 or 9 geography class or history class, folks, and they talked about that theory of plate tectonics, right? And continental drift. Do you remember that? Okay, from school. So just as a little refresher, for those of you who might have skipped that class, the theory of plate tectonics and continental drift right up until the 1960s was a theory that there would have been a large couple massive continents, okay? And chunks of them would break off and they would float on the Earth's crust around the ancient ocean. So let's just say that that big massive chunk of continent broke off and a slab became Europe and a chunk became North America and South America and Australia. Is that kind of a good refresher as the theory of plate tectonics? Okay, good. And it was only a theory until the 1960s. And then a famous Newfoundland geologist named Hank Williams, not yours, you American folks, our own Hank Williams, who also was a musician, a famous banjo player actually. He came here and explored this area with his colleagues from the mainland, okay, in the 1960s. And their pursuit was to find evidence to prove the theory of plate tectonics to be geological fact. Okay, so they explored this area where we are now, and they looked at the mountain ranges here and all the greenery. They took the rock hammers, they broke them open. You know what they determined? They determined that this is part of the Appalachian Shield, the Appalachian mountain range. You might find that very surprising because you know that begins in Georgia, okay? So you're standing on the Appalachian mountain range right here. Starts in Georgia, and that mountain range goes all the way to the northern tip of Newfoundland, okay? It's also some of the oldest rocks on the planet, 1.2 billion years old, the Appalachian mountain range. Now, like you, they're standing here and they looked across and they thought, that's a very peculiar scene over there on that horizon. First, they noticed that it was very red or orange in color, unlike all this beautiful greenery. And they also noticed it had no vegetation. Okay? So they were like, let's go over and have a look. When they went over there and they were looking at the rocks and they broke them open, guess what they determined? It was pretty much solid iron. Now, what happens when you leave iron out in the elements? Exactly. You're looking at rust. Okay? Now, when we're walking around, what are we walking on? The Earth's crust. Crust, exactly. Excellent. What's underneath the Earth's crust? Mantle. Right? Yes. Magma. Mantle. They were able to determine that that's actually the Earth's mantle. So the natural question, the logical question they asked themselves is, my God, how is the mantle above ground exposed like this? What do you think was a natural deduction or conclusion? Clearly, their idea that the continents broke apart was fact. And what happened here 360 million years ago is
subduction.
The continent broke apart and it floated across the ancient ocean. But it also, and this is what Hank Williams used as a metaphor, which was great, right?
Subduction.
Easy to understand. An accordion. He said the accordion, the continent broke open, the accordion expanded, the accordion contracted again, and when the continent started to contract, they scooped up the ancient floor, a big crack opened up, and the Earth's mantle rose. Okay, but the continents closed underneath it, leaving the first place they identified on the planet, the Earth's mantle exposed, and they were therefore able to prove the theory of plate tectonics.
And so,
wow, Michael! Gee, what, I didn't sell it? Tough crowd! Anyway, so it's one of the principal factors why this is UNESCO World Heritage